We're going to look at hyperbolas. Now, hyperbolas are actually very, very similar to ellipses because you'll notice here the formula looks really similar, but the difference is here. You've got a negative or a minus sign instead of a plus sign. So that's the only difference. And we also have asymptotes for hyperbola. This is the formula for the asymptote. So if you actually have your equation in this form, you can straight up just chuck your K's, A's and B's and H's into this and you'll get your equations for the asymptotes. I'll also show you another way of doing that too. So it's essentially by setting this equation rather than being equal to 1, being equal to 0 and then solving that. So there's two ways. So you can use that formula or the other way. We'll do it the other way. And there's two types of hyperbola that we're going to look at today. There's what's called the north-south hyperbola, which look like this. And you can see they're called north-south because they go up and down. And the other type is the east-west hyperbola. So they're the hyperbola that go to the east and west, so across. Now the difference with these, or how we can tell them apart, is the format of their equation. I'm just going to write these as sort of basic without any translations, H and K. The ones that are east-west have the x term first. So it'd be like x squared on a squared minus y squared on b squared equals 1. So that's x first, means it's in the x direction. Up and down is going to be y first. So y squared on b squared minus x squared on a squared equals 1. So that's the difference between these two types. It's just what term is first. The x if it's east-west, the y squared if it's north-south. So we're going to look at a few things here. We're going to try and find the coordinates of the centre. It's pretty much just like when we do ellipses. It's going to be a centre which is at these points, H and K. And we are then going to try and find the intercepts for the axes. That's difficult with these, particularly if you've got ugly translations. For these it should be okay, but sometimes these might be quite ugly. And we're also going to look at equations for the asymptotes, and they're these dotted lines here. So the first one we're going to look at is x squared on 9 minus y squared on 4. Now what you might like to do is actually write this so you've got the squared terms on the bottom. And we're going to look at, first of all, I guess here where the centre is. So the centre is going to be where you've translated h and k. And you can see here there's no translation on the x and y because they're just on their own. So the centre is actually 0, 0. Now for the asymptotes, what we're going to do is we're going to let x squared on 3 squared actually be equal to y squared on 2 squared. Now the reason we do that is that in this situation, this term and this term will be the same, and that will mean you'll have one thing minus itself, which will give you 0, and that means that that doesn't fit into this category or this equation of values for x and y. So this is not going to work here, and that's why these values that satisfy this equation are the values that go on the lines here where it doesn't work. Okay, so we're going to let that equal that, or if you want to, the other way of thinking about it, I'll just move this down so it's not so squashy, is instead of letting these two terms equal 1, they equal 0. So now what we can do is we can solve this. I'm just going to rewrite it, and I'll actually just write this as a 4, equals x squared on 9. I'm going to take the 4 up because it's multiplying this side. It was dividing on the left side. And then to find our asymptotes, take the square root of this side. Now that's going to be the square root of 4x squared on 9. It will also be the positive on the minus of that. And when we simplify, square root of 4 is 2, square root of x squared is x, square root of 9 is 3. So we actually have here 2 asymptotes, and we'll always have 2 asymptotes when we look at these type of equations. And I'll just put them in a box here in light blue just so it's all in one place. So my asymptotes are going to be y equals the positive and y equals the negative 2x on 3. So they're my asymptotes. So the key information here is in the blue boxes, that and also this. So with these bits of information we can actually sketch. Now I don't have lots of room here, but I'd like to do all this on this page so we can see it all. So I'll just do a little, very little sketch. Okay. So these lines here, 2x, 2/3 x is not massively steep. It doesn't have to be amazingly accurate. And I'm just going to write here, this is the positive, so this is y equals 2x on 3, and this is y equals, oops, I didn't write that. This is y equals negative 2x on 3, so they're my asymptotes. My centre is at 0, 0. Now to find where my intercepts are, first thing is we need to think, okay, what direction is this? You can see here we've got the x squared term first, so this is going to be one of these east-west type hyperbola, so I'm just going to pop the shape in. Now the shape should always approach the asymptote but not pull away from it. Okay, so it looks like it's going off towards the asymptote. Now to find the values here, because these are x-intercepts, once you know the type of intercepts, they're easy to find. So I'm just going to do my working here. So x-intercepts, so that's going to be when y equals 0. Chuck y equals 0 in here. You've got x squared on 3 equals 1. Okay, so that's when y is 0, this term disappears. And 3 squared, I should say. And the 3 squared will go up, so that's a 9. So you're going to have x squared equals 9. So that will give you x equals plus or minus 3. So you're really just chucking y equals 0 in here and solving. So that tells us that these points here are going to be 3 and negative 3. There are two intercepts for our hyperbola. So we've got the equations for the asymptotes, we've also got our centre, and we've got the, which we should put here as well, 0, 0. And we've got the axes intercepts here, negative 3 and 3. So they're the three things we're going to look for when we look at a hyperbola, and also the shape. So I usually just decide on the shape before I'd go and find intercepts, because once you know they're y-intercepts or x-intercepts, you know which one to make 0. Okay, so we can do the other ones now. They're all kind of similar. Once you've done one, we'll just put this on the next page so we can see it. Okay, so this one, very similar, the next one, sort of just around the other way. And we'll do all the steps. So for B, we've got y squared on 9 minus x squared on 4 equals 1. Okay, what we're going to do first of all is find our asymptotes. So we're going to let y squared on 9 minus x squared on 4 equals 0 instead of 1. We can solve this. Y squared on 9 equals x squared on 4. The 9 is going to go up because it's multiplying, and then we're going to take plus or minus square root of all that. Square root of 9 is 3, square root of x squared is x, and the square root of 4 is 2. So our asymptotes are going to be at y equals 3x on 2 and y equals negative 3x on 2. We also know the centre. There's no translation. We'll be at 0, 0. And the shape for this one, you can see that y is first, so it's going to be one of those north-south ones. So that means we are going to need y-intercepts. Oops. So when x equals 0. So if we do that, put x equals 0 in here, we're going to get y squared on 9 equals 1, y squared equals 3, y equals plus or minus, I should put 3 squared, y equals plus or minus 3. So we know what our y-intercepts are going to be, and then we can sketch this one. It's nice and easy. I'll just do it here. So same kind of idea. Put these asymptotes in. 3 over 2 is a bit steeper than, oh, that was a bit dodgy, we'll do that again. It's a bit steeper than y equals x. Now, you'll probably do that a bit better than mine. Mine looks a bit wavy. We've got y equals 3x on 2, y equals negative 3x on 2. The centre, they go through 0, 0, and our intercepts are at 3 and negative 3. And again, that shape sort of just going out to the asymptotes. We might just continue them out a bit more. So it looks a bit more, less like a straight line. It's a bit dodgy. Like that. There we go, that's better. And label our axes as well. So that's a north-south type hyperbola. with your asymptote shown, your center shown, and your two intercepts, the y-intercepts this time. All right. So again, for the last two, this one's kind of an interesting one. It's got a bit less going on. So we'll look at this again. So first thing I'm going to do is I'm actually going to do the center here for this one. Center is going to be at 1. Remember, it's always opposite sign, -2. That's the center. To find the asymptotes, same deal. So we're going to let x minus 1 squared minus y plus 2 all squared equals 0. Okay, and what we could do here is we can expand this out and then solve it, which is sort of a bit ugly. There's a little bit of work with that. Or what we can do is we can just shortcut it. So we've got y plus 2 all squared equals x minus 1 all squared. Don't factorize it, leave it tied up like this. Then we've got y plus 2. We can now do the square root of this side, plus or minus the square root of x minus 1 squared. And the cool thing with that is the squared and the square root cancel. Yeah, so you actually end up with just this, y plus 2 equals plus or minus x minus 1. And we've sort of got here, I suppose, two cases. So I'm just going to solve this for y, plus or minus x minus 1. This will be a -2 over here. So the two asymptotes are going to be y equals, let's do the plus first, plus x plus a -1, that's -1, and then take away 2. That's going to be x take 3. The other version is the negative version. So negative x, the minus and the minus becomes a plus, and then that's just a -2. This doesn't change, yeah, because you've put it on this side, it's a negative. It doesn't get affected by this plus minus part. So this is going to be, negative x and minus 1. So we've got two asymptotes, y equals x minus 3 and y equals negative x minus 1. They're asymptotes. I'll put a box around them. And in terms of the format here, we've got x first. So this is going to be a east-west type hyperbola. So we know the shape for it. And that means that we don't need to worry too much about y-intercepts. But because this is shifted, we should just check anyway before we go and do things. So I'm just going to put my axes in. Now the center here is at 1, -2, which is here. And what that means is that the lines which create our asymptotes are going to intersect here. So at 1, -2. So we really have to think about these two lines here. This is x minus 3. So for the first one, I'll color code these. Okay, so we've got y, oops, I'll just write it here, and this is going to be light blue. X minus 3, that has a y-intercept at -3. And when x equals 3, y equals 0. So it's this straight line here. Looks like that. Whoops. So that's y equals x minus 3. The other asymptote, do that in green, has a intercept at -1. It's going to be going this way. And when x is equal to -1, that would be +1 minus 1, that'd be 0. We've got an intercept there. Any straight line, you only need 2 points to join that up, and there's a unique straight line. So you only need the 2 points, the 2 intercepts to work, to draw your line. So they're your asymptotes. Now, looking at this, we're not going to need y-intercepts because we're not far enough over to intercept here. So we can just do look for our x-intercepts. So similar to how we've done that before. X-ints, that's when y equals 0. We're going to have x minus 1 all squared minus 0 plus 2 squared equals 1. X minus 1 squared, this is going to be 4. X minus 1 squared, add that to the other side. X is going to be equal to plus or minus the square root of 5. Okay, because we're going to take the squared over. Forgot my minus 1. and then x is going to be equal to plus or minus the square root of 5 plus 1. Now that's kind of ugly, so you can actually find the solution to that by using your CAS as well. So like an approximate, we'd have square root of 5 plus 1. Oh, do that again. Square root of 5 plus 1, that's better. And just do control enter. So it's about 3.23. And the opposite, we want the negative as well. And make sure I'm using the right one. And we'll just approximate that. So negative 1.23 and 3.23, or 3.24. So we'll just round it to 1, 3.2 and negative 1.2. And negative 1.2. So they're going to be our intersects. So 3.2, 1, 2, 3 is about there, sort of there. We can actually sketch in the shape. And this is going to be our root 5 plus 1, comma 0 intersect. So that's that one. And that's a decimal, it looks like a comma. And negative 1.2 is sort of there. So they've got the symmetry about them because they're 0.2 off the intersects of these asymptotes. Yeah, so 0.2 off the 1 and 0.2 off the 3. So there's a beautiful symmetry about it. It's really nice. So just put in that intercept there, which is, I'll do it in the exact form. So this is the negative root 5 plus 1, 0. So you've now labelled in your intercepts and your asymptotes with their equations for y, and you've got your basic shape as well. So they're the key things on your centre. Make sure you label your centre. So they're the key things that you're looking for when you're graphing a hyperbola. And in the next video, I'll do part D of this question, but using the CAS, so you can see how quickly you can do these with your calculator.